Congratulations, you made it to the end here. You are the dedicated people. You are the people who believe in getting the most out of your conference. You are the people whose flights maybe leave tomorrow. So I am indeed Russ Olsen. I work for a company called Cognitech, and we do functional programming, and we're the people behind the Clojure programming language. And if we were to run into each other at the, after the conference is over, we might talk about Clojure and functional programming, and I might try and explain things to you, which brings me to the question that I really want to address in this talk tonight, which is, what's holding us back? Why can't we do this thing that we do? Why can't we do it better? I've been a software developer for a really long time, and today, the hardware is tens of thousands, hundreds of thousands of times, sometimes millions of times faster, bigger, better than it is when I started. Are we tens of thousands of times better than 20 years ago? I think we're better at developing systems than we were 20 years ago, but tens of thousands of times, millions of times? I don't think so. What's holding us back? Why can't we do this thing better? And this is a question that is kind of near to my heart because it's really the question that drove me into software development in the first place, because I was not originally a programmer or a developer. I was originally a mechanical engineer. And what happened was I started doing mechanical engineering, and I found it really, really frustrating because mechanical engineering is all about physical things. And so it's all about the limitations of physical things, right? In mechanical engineering, there's always friction, and that's the equation for friction. And no matter what you do, no matter how good your gear is, there's always going to be friction. There's always going to be stress. If you build something and put some weight on it, there's always going to be stress, and it's always going to bend. And if it's there long enough, eventually it will break, right? Mechanical engineering is all about the physical limitations of the world. This is the equation for the efficiency of a heat engine, which is an elaborate way of saying that you can't get all of the work out of, say, a motor or a gasoline engine that you put into it as fuel. And this thing is the second law of thermodynamics. This is built into the fabric of the universe. There's no getting around it. And so mechanical engineers, they have to deal with all these limitations. And that's why I got out of mechanical engineering, and I got into this other profession where instead of gears and pulleys and whatever, you have data and algorithms. And the thing you're trying to make is maybe information or maybe even wisdom, right? And it just seems like there's not the physical limitations there. So what's holding us back? Why can't we do this better if there's not friction and all these other physical limitations? And I have an answer. I know the answer. And I have to admit it. It is me. I'm the reason we can't do this better. It's my fault. And it's not just me, fortunately. It's also all my colleagues at Cognitech. It's their fault. It's all of our faults. But it's not just us. It is also all of you. The reason we can't do this better, if your raw material is data, if your tools are algorithms and programs, the reason we are not doing this better to make the output of wisdom is right here. It's in all of us. We are not smart enough, right? It's us. We are the primary limitation in what we do. But there's some good news even in that, and it is this, that every person in this room knows something that someone else in this room would be better off knowing. We all know these things, but it's stuck in her head, or his head, or their head, and we would all be better off if we all knew what we all know. And so what I want to talk about tonight is really ways that you can explain things, technical things, to your colleagues, so that you can make them smarter, so that you make your company a better place to work, so that everything happens more efficiently, so that just generally you're making the people around you smarter. So, and in particular, I want to talk about 5 specific things that you can do to explain technical things better to your colleagues and the people you work with. And I want to say, I am really talking about you. Okay, I'm up here, and maybe you're thinking, well, he's the guy explaining, right? We've had this great conference, and there's been all these really good explainers. Isn't that all we need? And the answer is no. The kind of explaining that I'm doing right here, right now, is kind of the least important explaining that goes on. Not because it isn't fun or informative, but because there's so little of it, right? You're going to listen to me for 40 minutes, and then you're going to go back to work, and you're going to spend hour after hour after hour answering questions like, hey, how does this work? Why did you do that? What's the design of this system? And that's the kind of explaining, just the sheer volume of that kind of explaining is what I want to talk about. So 5 ways that you can be a better explainer. Okay, so number 1, here's my first way. You need to take explaining seriously. Right? And when we're technical people, when we take something seriously, I think it's one of the most important parts of your job. When we take something seriously, there's only one thing we do. We're technical people. We have a plan. We plan everything. Sometimes those plans are written down. Sometimes they just exist in our heads. But we plan everything, right? If you think about Agile, right? And I'm not talking about the kind of thing you get certified for, but really, Agile kind of as an outlook. Agile, as it came to programming, is 2 things. One, it's the best thing that's happened to programming, right? Think about the waterfall days, if you're old enough to experience that. It's one of the best things that's happened to programming in ages. And it's also, number 2, you can sum up Agile by saying, don't overplan everything. And so, we plan things when we take them seriously, and every explanation needs a plan. And what a good explanation plan looks like is kind of like a Dutch master painting, right? There's buildings, you can see the people. If you only had this painting and you were dropped into that scene, you could find your way around. And that's the key thing about a good explanation, a well-planned explanation, is that it helps you see where everything is. It's not just a bunch of facts, or in this case, a bunch of buildings. They're all in the right place. So I say you need a plan for your explanations, but the fact is that your explanations will always have a plan. The only question is it the plan that I think about? And I'm not talking about like, writing design documents. I'm talking about somebody says, how does this work? And I say, let me think about it for a minute. Okay, I got a plan. And go at it. Start explaining. So you will always have a plan. Your plan can look like this, or if you don't think about it, your plan can look like this, right? There's still stuff there, but you can't tell how everything goes together. And that's the characteristic of a good explanation, is it's not about facts, it's about how things go together, right? So yeah, there's an ear there. You can see an ear and a nose and a mustache, but could you identify this person if you had to? I'm not sure I could. So what are plans for explanation? What am I talking about? What are plans for explanation? It's not rocket science, right? One plan for an explanation is the zoom-in plan. You start with the big picture, maybe the world, and you work your way down until you're here in Amsterdam. You start with the big picture, and you work your way to the details. Hey, how does this system work? What are we doing? Maybe you've got a new colleague, and you're going to work on some code with them, and they don't know what's going on. So you think for a minute, and you say, okay, I have a plan. I'm going to use the top-down plan. So let me start by saying, hey, we're trying to get rich. And we're trying to get rich by selling pet food on the internet. I don't know. And so we're building this e-commerce site, and we need a login screen. And you and I are working on this login screen. That's a top-down explanation. It starts with the big picture, and it works its way to the details, right? And the key thing is, it tells them where everything fits together. We're trying to get rich to the login screen. You can work it the other way, too. You can start small and work out to the big picture, right? So I start in Amsterdam and work my way out to the world. We're building this login screen because we're building an e-commerce application, because we want to sell pet food on the internet, because we want to get rich. Good luck with that, but that's a good bottom-up explanation. Another plan for an explanation, so you can go top-down, bottom-up. You can do a process explanation, which is to follow things through time. So think about how a car gets built, right? Car, you start with the frame, you maybe put the engine on, the wheels on, that kind of thing. How does a web application work? Well, here's a process explanation for a web application. The request comes in, it gets authenticated and authorized, it goes to the controller looks at it, consults the model, picks a view, sends everything to the view makes a result or a response, and the response goes out. That is a process explanation of a web application. Again, none of this is rocket science. It just takes a moment of thought. How does this work? You think for a second, and off you go. Process explanations are so common that we have UML diagrams for them. Sequence diagram, I guess. But probably the most useful explanation plan of all is what I call simple to complex. If you have some difficult thing you're trying to explain, some complicated, where the heck do I even start kind of thing, what you do is you start by explaining a cartoon version, a highly simplified version of the thing, and then you start adding details as the person gets more context and starts figuring out what's going on. So for instance, as I say, I work for the company behind Clojure. Clojure's a programming language. Every now and then, well, if you're a new Clojure programmer or if you're brand new, you will see literals like this. And, so a new Clojure programmer, maybe it's their first day, they will say, what is this? And I have to decide how to explain this thing to them. Well, it should look reasonably familiar to all the programmers in the audience, right? Put some commas in, and that looks like an array, right? Well, in fact, in Clojure, while that thing is called the vector, acts a little bit like an array, and it kind of takes the place of an array, it is actually something more complicated. It's actually a persistent, immutable data structure that's built, behind the scenes, there's this tree data structure. That's not what you tell a beginner. What do you tell a beginner? You say, that's pretty much an array, right? You tell them that, and then later on, after they've gotten some experience and they have an idea of what they're doing, you go back and you fix it. So what am I saying? I'm saying you lie, right? You lie. You tell them a story. It's pretty much an array. Don't worry about it, right? It's not true, but you will make it true later by kind of cleaning up the lie. All right, so there is one problem with kind of the simple to complex explanation, and it's not actually a problem with the plan, with the explanation plan. It's the problem with the expert who's walking by you as you say, that's an array. Because if you do this enough, eventually you will get this expert walking by you as you're saying, that's an array. And this person will say, stop, you're lying. That is not an array. That is a persistent data structure, blah, blah, blah. And so the thing to do there is to smile stupidly and let them sort of get it all out and go back to your lie. Explaining is so important that you lie, cheat, steal, you do anything to get the idea across. And the world is full of people who know about a thing but have no idea how to explain the thing. And in this particular case, if you have something really, really complicated, the expert's gut reaction is to try and explain everything all at the same time. And the problem is, if you try and explain everything all at the same time, you will end up explaining nothing forever because you'll lose the person. So what am I saying? That expert comes by and says, stop. So how do you deal with that? In summary, you ignore the expert. That's the stars stand for a 4-letter word that means ignore. So that's number one. Have a plan for your explanation. And again, not a complicated thing. You just think for a second. Top down, bottom up, process, simple to complex. All right, so that's number one. So here comes number two. Number two is that you should be an Agile explainer. And I don't mean that you need to become a certified Scrum Master explainer. No. What I really mean is go back to the guts of Agile, to the core of Agile. And the core of Agile I think of as just kind of a recipe. You do the thing, you measure the result, you fix the problems, and you do it again. All right? That I think of as the Agile recipe. So in explaining, let's think about this in terms of explaining. Doing it, you can come up with an explanation, right? No problem, come up with an explanation. Certainly, if I knew what was wrong with my explanation, I could fix it, and I could go back and do it all again. It's the measuring part that we have problems with, right? How do you build a unit test for an explanation? Do you put electrodes on the person's head or maybe drill in? It'll make you an unpopular explainer. It's not really what I mean. What I mean is to look for the signs that your explanation is failing. Now, these signs are pretty obvious, but I have seen enough people explain things and ignore the signs that I feel like I have to mention them. So what are the signs that your explanation is failing? Silence. They just sit there and look at you. Or they look at you with this blank look on their face like, God, I wish I were anywhere else. Or, and this is the key one, they ask the same question over and over and over. Can we go back to this? I don't understand this. Wait a minute, can we talk about this again? That means that your explanation is failing, right? And there is a common reaction if you're trying to explain something to somebody and they keep saying, no, let's go back to this other thing. You think, this person, yeah, I don't think so. Well, let me tell you, if you undertake to explain something to somebody, it's on you. It's not on them, right? They have come to you, please help me understand this thing. It is your job to help them understand the thing, okay? If you think about what is greatness, like we all want to be great at what we do. Well, what's greatness in explaining? Greatness in explaining is not, I have this person who's pretty knowledgeable and I can get them up a level. That's good, there's nothing wrong with that. That's not greatness in explaining. Greatness in explaining is also not, I have an expert and I give them one extra fact, right? And how cool is it? I taught the expert something new. That's wonderful, but it is not greatness in explaining. Greatness in explaining is to take a person who doesn't have a single clue, has no idea, and get them up to the point where they can start learning on their own. That is the prime directive of explaining, and it is on you, and you need to watch for the signs that your explanation is failing. But fortunately, most technical explanations fail in a particular way. So if you look for this one particular way that your explanation might be failing, you'll probably get 60 or 70% of the failures. And the primary failure mode for explanations is something I think of as a gap. And it has to do with the way people learn things and internalize knowledge, right? So I'm a native English speaker, and when I look at that color, I think of the word red. You don't have to think about it very hard. I just come up with the word red. But let's say I decided Amsterdam was a beautiful city and I wanted to spend some more time here, and I wanted to learn some Dutch. So now I'm learning Dutch, and there's the Dutch word, which various people this week have convinced me I cannot pronounce, so I apologize. There's the Dutch word for red. And if I were learning Dutch, in the beginning, I would go through this painful mental process of, what's the Dutch word for red? The Dutch word for red is that. Okay, I have the Dutch word for red. But if I work at it, and maybe even learn to pronounce it, if I work at it, after a while, it'll just come to me. I'll have internalized the knowledge of what the Dutch word for red is. And that's the way we learn. We stop thinking about it, and we just know it. And that is great for learning. It's horrible for explaining. It is horrible for explaining because as you internalize knowledge, you forget that there's anything to know. So experts know the thing so well that they forget that there's anything to know, and so they forget to explain things. So let me talk for a second just to the people who are sitting here thinking, well, I'm new at this. I don't have, I just graduated from school and maybe been working for a few months. I don't have anything to explain. You are in the best position to explain things because you still remember all of the things that were new. You still remember this mental lookup process. So don't think that you can't contribute to the explaining. So the gap idea, I first sort of realized that that's what was going on years ago when I was teaching Ruby on Rails. For a while, I taught this course. If you don't have any programming background, but you want to learn to build web applications because you have some idea for a startup or something like that, come to my class, and I will help you get up and running with Ruby on Rails so that you can build basic web applications. So imagine you're me. And it's the first day, and you're standing in front of a bunch of maybe not really technical people who've never really programmed before, and you're trying to explain a programming language and a web application framework to them. Where do you even start, right? And I remember there was this one particular class, I don't remember what I started with something, and there was a woman in the back, and let me say, she ended up being one of the star students in that class. But that day, she was having trouble. She was doing all the things. She was saying, can we go back to this? I don't understand this. Can you explain this again? All of the things that meant that I had left a gap in my explanation. And so I tried different things, and nothing was working, and suddenly she figured it out all on her own. It wasn't me, it was her. She figured it out, and she said, oh, Ruby is the language. Rails is the framework. How could you come to a programming class and not know Ruby is the language, Rails is the framework? Oh, if you're not technical and I told you I would teach you Ruby on Rails, isn't that sort of the first thing you should have said? It's on you. So that's a gap that I left, that I've never, ever left again. And when you're explaining technical things and you're doing it several times, look for the gaps and make sure you fill them in. All right, so that was number 2. All right, number 3. Number 3 takes me to the world of sports, which is not a happy place for me. Not really at all. But I have done an academic study of the games that people play in sports, and I've come to the remarkable conclusion that there's actually 2 different kinds of games in sports. There is golf and tennis and American baseball, and they're all in one group. And then there's football, your football, and my football, and hockey, either ice or field hockey, and they're in a different group. All right, so we've got these 2 groups of games. What's the difference? In something like tennis or golf, you play the game until it's done, right? If it takes all day, you just play it till it's done. Football and hockey, there's a clock. The clock runs down to 0. When the clock hits 0, the game is pretty much over. So here's the question. What kind of game is explaining? We tend to treat it like it's golf or tennis. We just keep doing it until we're done, until we get to the end. But the fact of the, so, I'm going to teach you about web applications. So how do I start? Maybe the stateless nature of the HTTP protocol. Maybe I'll start with the whole history of computer science from the 1940s on. Maybe the history of programming languages. I'll get to those web applications eventually. The thing is, explaining is a timed event. Okay, there is a clock in every explanation. When the clock hits 0, you are done explaining. Oh, your mouth might still be moving, the words might still be coming out, but you are done, right? Where is this clock? It's in the head of the person you're explaining things to. We all have this capacity to absorb information. It's different for different people, and it's different on different days for a single person. But we all have this clock. I'm willing to bet that your clock had more time on it yesterday morning than it does right now, right? You get bombarded with information and the clock runs down. And so there's implications for how you explain things in this. And the key one is you put the important stuff first. Okay, you remember that thing about the plans, have a plan for your explanation? That is the most important thing I am going to tell you today, and that's why it's first, right? Before you tune me out, okay? The other thing that you need to keep in mind is that terminology is not the important stuff. I don't know if math professors do this here, but in the United States, in about half of the math courses I've ever attended, you go in on the first day, and the professor says, let's start by defining some terms. Oh, God, no. Let's do anything else. Let's not start by defining some terms, right? Terminology is really important. Getting the words right is really important to learning a subject. So don't get me wrong. But the problem is that to a beginner, terminology is just a lot of mumbo-jumbo. You need to lead with the ideas, okay? So take computer security, right? In computer security, we have authorization and authentication, right? They're two words, but they're also two ideas. So now consider these two explanations of authorization and authentication. Here's explanation number one. And remember, the clock is running, right? This person is going to tune you out. All right, explanation one goes like this. In computer security, there's two related but distinct concepts called authentication and authorization. You're just out of time. All right, now try this. Here's number two. In computer security, there's two related ideas. Who are you and what are you allowed to do? You just ran out of time. Which one of those explanations is actually an explanation of something valuable? The one is just, oh, there's a couple of words. The other one is, oh, there's these two ideas. Maybe later I'll hang some words on them. Terminology is not the important thing. But there's a bit of good news with the clock as well. And the good news is that you actually have some control over the clock, right? You can add time to the clock. The bad news is that you can also run the clock right down to zero. Let's start with some terminology is one of the best ways to run the clock right to zero, right now, all right? But there's other ways. You can say discouraging things. This is really hard. Yeah, thanks. Most people never get this. The reason I'm thinking of computer security is I actually went to a 9-hour, all-day computer security seminar once, many years ago, and the professor walked in, and there I am with my pencil and my notebook, and he stands in front of the room and says, yeah, most people never get this. Thanks a lot, you know. Hi, I'm Russ Olsen. I'll be your instructor, and you are screwed, is basically what he said, right? Don't do that, right? If something is hard, tell them it's hard after you've told them. Supply them with small victories. That thing about having a plan that I told you in the beginning, that is the hardest thing I'm going to tell you today, right? Then you feel good, right? I got through the hard thing. The other thing you can do is organize your explanations so that people have a feeling for where they are, so they know, oh, I'm in the middle, I'm right at the beginning, I'm getting towards the end. So that's why I like the 5 ways, right? This is 5 ways to be a better explainer. And in fact, the good news is we have now finished number 3, so you're more than halfway there. Number 4. Number 4 has to do with this word. You're all programmers, or I think most of you are programmers. What does this acronym mean? Don't repeat yourself. We get this drilled into us, right? Do not program with the copy and paste keys, right? If you have an idea in a program, express that idea once and then refer to it everywhere else. That is an important concept in programming. So dry is really important in programming, but explaining is about people, human beings. So let's think about this word dry, right? The English word dry, it obviously means no water, no moisture, but it has some other meanings. It means having no adornment, no decoration. That book was very dry. It was just the facts, right? That's not a great thing. Dry also means impersonal. Oh, that Russ Olsen, you talk to him, he's so dry, it's like he's a robot. But most damning of all, dry, at least in American English, also means without butter. I want that toast dry, means without butter. Dry, don't repeat yourself, is for machines, it's for mechanisms. It's a design principle for software, but we get it drilled into us so much that we tend to do it in explaining. And the thing is, we are not machines. People like redundancy. People like it when you explain things and repeat yourself, okay? So I would like to propose, when it comes to explaining, an alternative acronym, which is repeat yourself enough, which is rye, which is kind of whiskey, so, you know. That's also, it's Russell's Reserve Rye. I don't know if you can see the picture, but you can find anything on the internet. Why would you repeat yourself? You would repeat yourself for emphasis. If you have an important point that you want to make, you repeat yourself for emphasis. Let me say that again. You repeat yourself for emphasis, right? You also repeat yourself, more importantly, you repeat yourself to remind the person of the context, right? And this is what everybody hates about government forms. I bet your government forms are exactly the same as my government forms, which is they'll say things like this: refer to section 9.7 before proceeding. Please just give me a hint as to what is in section 9.7. It might be really, really important. You know, 263 million volts. I might want to remind you of that. Repeat yourself for context, to remind the person of what you told them before. Remember you needed a plan for your explanation? You remember you needed to be agile? Right? Those are all important, but also repeat yourself. All right, so we're almost done. We're now at the fifth thing, and the fifth thing has to do with this book. This book is called Numerical Methods That Work, and it's by a guy named Foreman S. Acton. Wherever you are, Foreman. It's a very old book. See, when I was an undergraduate, when I was at the university, I fell in love with a mathematical technique called numerical analysis, and that's what this book is about. And numerical analysis is the technique where you can solve difficult equations without being too smart, that's me, but if you have a computer. And numerical analysis has this interesting characteristic that most of the time it gives you wonderful answers, but occasionally it will go horribly, awful, god-awful wrong and give you an answer that's not even close. That's crazy, right? And so I fell in love with numerical analysis when I was at university, and I got every book my university library had about numerical analysis, and I read them all, including this one. Well, not specifically this one. I bought this one on eBay. I didn't steal it. And there was this beautiful spring afternoon, so of course, where was I? I was in the library doing numerical analysis, and this book was laying on the table, and there was a window. And I looked at the book, just glanced over, and there was something on the cover, right? And it was just, you could see it if the light was just right. It was like something imprinted into the cover, but not actually printed, over there by the title. It was right there. And so, it sort of made me crazy. It's like, what the heck is this? What? And so eventually I did that thing, that thing that people do in monuments. You get a piece of paper and a pencil, and you scribble, and you get the outline of the thing. And so I did that. And that's what I got, and that was the mysterious word. Usually. Numerical methods that usually work, right? It's one tiny little joke. It's just one tiny little joke. That word usually is nowhere else in the title, just there on the cover. It's one tiny little joke, and it made me remember that book for decades. I can't remember any of the other books I read that semester, but I had no trouble finding Foreman S. Acton and his Numerical Methods That Work 30 years later. So what am I saying? When you're explaining, mix in some humor. It's like the magic ingredient. All right, so you're going to mix in some humor. The question is, are you funny? Right? I think of myself as sort of funny. I'm not really funny. I can sometimes make people laugh. So if you're really funny, then I really have nothing to add. Go with God, do your best. All I would say is don't let the jokes get in the way of the explanation, right? But what if you're like me? What if you're sort of funny? Lots of people are sort of funny. Well, don't let the joke get in the way of the explanation. subtle is better. That word is only one place in that book, and that's what makes it funny. And for God's sake, don't explain the jokes. Jokes are not a place where you want to explain things. All right, what if you're not funny? What if you're not funny and you know you're not funny? Well, congratulations, you're way ahead of the people who aren't funny and don't know it. But if you're not funny, it kind of doesn't matter. If you're not funny, it doesn't matter because what I'm really talking about here is not really humor. It's not really jokes. It's humanity. You need to mix some humanity into your explanation. You need to show up when you explain things. 7 simple words. If you don't care, I don't care, right? You need to show up. You need to show the person that you're explaining the thing to. And by the way, the first part of caring about the person you're explaining something to is to make sure they really want to hear your explanation. You know, explaining is either a gift or you're being a jerk, and it all depends on whether everybody's a volunteer in the room. But assuming everybody is a volunteer, you need to show up. You need to care about the thing and care about the person, and that will make your explanation live. So what do we have? Number 1 is you need a plan. Bottom up, top down, just take a minute, think. Simple to complex, a process explanation. Take a minute and think about your explanation. Number 2 is be agile and look for the signs that your explanation is not working. And look for the gaps in your explanation. Watch the clock, right? Everybody has a clock, and you need to get the important things first. Repeat yourself enough, maybe have a little rye whiskey while you're at it, and finally show up to your explanation. And that's my 5 things, but I do have one final bonus thing that I want to mention, and it takes me back to where I started with all of us, all of you, right? It is no secret that the world is kind of a mess today, right? Things could be better, and despite what you read on the internet, this is not a recent phenomenon. So I started this by saying we could make our companies more efficient. You could make your coworkers better at their jobs by being a good explainer. But if you think about it, if you're interested in making the world a better place, how about making the person next to you a little bit smarter? That is one of the few things that a single person can do right here, right now, to make the world just a little bit better place. So we're going to break up in a few minutes. I wish you all a safe journey home, and I certainly hope that when you get home and you go back to your lives, that you start explaining things. Thank you very much.